the range equation. It's terrible. It really is. So, and I've actually made this video before, but I'm going to do it again because I didn't like my old videos, so here we are. Okay, so the range equation says if I launch a ball with some initial velocity at some angle, then it's going to travel some distance x, where if it starts at x equals 0, and that final position is called the range. How far did it go? And so, the range equation, get it out. Okay, so the initial velocity squared, sine of twice the angle divided by g, where g is 9.8 meters per second squared. I hate it. I hate it because students take this, and teachers too, they take this, okay, this is the key thing. This is the range equation. But it's not a real thing. It's a solution to a particular problem. So let's solve that particular problem and show where that equation comes from. Then you can kind of understand projectile motion. You can see where it applies and where it does not apply. Okay, math starts now. Okay, once I shoot a ball in the air, then there's only one force on it, and that's a downward gravitational force. So that means that the horizontal velocity is constant and the vertical motion has a constant acceleration. So I can actually break this motion into two problems. X motion, where x final is x initial plus v x initial t. I can say t starts at time t equals 0. Okay, and I'm actually going to say x is equal to 0 too. Okay, and that's it. Right? There's no other equation in the x direction. There's nothing else I can do because it's moving at a constant velocity. Everything else is boring. And then I have the y motion, which has really just one equation also, and it says the final y is initial y plus initial y velocity times t minus 1/2 g times t squared. So the minus 1/2 g t squared is because it's accelerating in the negative x direction. Okay, so when I break this motion into two problems, this two-dimensional problem into a one-dimensional x motion problem and a one-dimensional y motion problem, that works in this case because I have a constant force that only doesn't depend on other directions. In that case, the key is time. The time it takes to move in the x direction is the same time it takes to move in the y direction. So if I use the y motion and solve for the total time, I can use that time and solve it in the x motion. Now there is one problem here. So I shoot this v0 at some angle theta. So I need to find the initial x velocity and the initial y velocity. So the initial x velocity is going to be v0 cosine theta, and this is going to be v0 sine theta. Right? Because sine of the angle is opposite over hypotenuse. If I solve for that, I get this. So this is my initial y velocity. This is my initial x velocity. Okay, be careful. It's not always sine theta for the y velocity. It depends on how you set your angles up. Okay, with that said, let's look at the y motion equation. So here I have this ball is shot up with some initial y velocity. It goes up and it comes back down. So that means that my initial y velocity is this. My final y position is 0 because it gets back down to the ground. My initial y position is 0. So I have 0 equals 0 plus v0 sine theta t minus 1/2 g t squared. I put in, instead of initial y velocity, I put in the total velocity v0 times sine theta. So now I can add 1/2 gt squared to both sides. And I want to solve for the time, but I can divide both sides by the time. And then I can multiply both sides by 2 over g, and I get t equals 2 v0 sine theta over g. So that's the time. Okay, so now I can use that time in the x direction. So let's say that the x position starts at 0, so I get x equals v0 cosine theta t. But now t is this, 2 v0 sine theta over g. So this is going to be equal to, I have 2 v0 squared cosine theta sine theta over g. And that's the same equation. Okay, but let's think about what this means, because this is really important. Suppose I start and I shoot the ball completely horizontal. Theta would be 0. In that case, the initial y velocity is 0. So it's not in the air for any time. So it doesn't go anywhere. Okay, because cosine theta is 1, sine theta is 0, but they multiply by each other and I get 0. Now let's assume I shoot it straight up. So now theta is 90 degrees. So in that case, cosine theta is 0. It doesn't move horizontally. It spends time in the air though. So that would also be 0. So when would this be the best? Well, let's just see if I could plot this. I'll leave that one there. Let's say I plot theta, and this is cosine theta, and this is sine theta. So if I plot, this is cosine, sine, and this would be sine times cosine. Right there. So you notice it's smaller because this is at 1, right? The maximum that can be is 1. So these are always smaller than 1. When I multiply them together, I get something even smaller. So that was my answer right there. And it turns out that this is actually at 1/2. So we get sine theta, cosine theta equals sine of 2 theta over 2. So when I put that in right here, I get v0 squared sine 2 theta over g. And that's the same thing. Yay. Okay, wait. I'm not done. When would this not work? Okay. What if I do this? What if I shoot from some height and land at a different height? Where would my equations change? This is still fine. This is still fine. This, not fine. Not fine because now my final y is some value, let's call it negative h. Let's call this h. So I start with my initial y as 0, it ends up below there. So down here, now I can't do this simple thing right here. I'm going to have to actually use the quadratic equation to solve for this. It's actually going to be in the air for a longer amount of time because it takes longer to get back down to the bottom. So the point is you can't use that range equation. Okay? That range equation only works for a ball starting from and ending at the same height. But it does tell you that in this case, I get the maximum range right here at the middle at 45 degrees. And if I go a little bit higher than 45 or lower than 45, I can get the same height, right? So these two have the same height. So there's two. So I can shoot it at a 20-degree angle, or I think it's a 70-degree angle. They actually go the same distance. I said height. When else does this not work? There was another case, but okay. Well, that's fine. That's the range equation. I don't like it. And you shouldn't either. But if you have to use it, you have to use it, and I get that. Okay.